All right, so drag the appropriate labels to the respective targets. Labels can be used once, more than once, or not at all. And so what we're doing here is we're labeling these R or S. In these, we're having a bit of a problem. That is that these H, they're oftentimes not on the back, are they? Yeah. And so what we need to do is we need to use our, well, either we need to rotate them so that they would be in the back, or we would need to use our tricks. Remember the 3 tricks I showed you to do these easily, even if the H is not in the back? Okay. So the first thing we should do here is let's just look at what we would get if we did it like so, okay? So first off, on this one right here, what's the first priority? Yeah, the CL. What's the next priority? This one right here? Yep. And then the next priority is? This one here, right? Yeah, and so we would be counterclockwise here. But I guess as you can see, because I have my answers on there right now, that's not correct, is it? Why is that? Because this one's in the back, isn't it? That's not the lowest priority. And so what would we have to do? Well, we have to take something that's in the chain, and then we would either flip their priority if the hydrogen's coming out towards us, right? Or we would exchange the hydrogen that's in the plane of the paper with the one in the back, and then flip priority, right? Those would be the 2 rules that we need to use here. Okay, so is this coming out towards us, or is this in the plane of the paper? That's the question we have to ask ourselves. Typically, this stuff is the stuff that's in the plane of the paper. Okay? This is obviously not in the plane of the paper, right? Yeah. And so if you look at this as a tetrahedral, like this would be one, and then this would be the other. Can you see that? So tetrahedrals always have 2 V's. This would be one. That would be your other one. Because that one's the one that's tilted away in towards you, isn't it? Because we're looking down here. Okay. Can everybody see we're kind of looking down this way? Okay. And so we would get S normally, but we have to flip that. We're looking the wrong direction, aren't we? And so we end up with R. No, so we're looking down. So that means the V that's coming in and out of the paper is this right here. This is the H in this group. Okay? These ones would then have to be in the paper. They'd be on the plane of the paper. Same thing here, we're looking down this. And so we're going to get the same, essentially the same results. So here we look, we get CL would be our highest priority. Next highest priority is that again. And then next is that, right? Again, we're not in the correct orientation. So we look, where are we looking down at? Well, we're looking down this, right? From the top. So the thing, the V, that would be coming out and away from us has to be this. Okay? The V that, basically look at it like this way. If you were looking at these as V's, are you looking down the V? Or are you looking at it on the side? And see, this is a V that you're looking at the side. You can see the full V, can't you? This, you can't see the full V, can you? It looks tilted, it looks scrunched, right? Because your perspective is looking down the V. And that means whatever's coming out towards you is coming out towards you in this. Whatever's going away from you is the one that's going away from you. Can everybody see that V structure? That's the easy way to deal with 3-dimensional structures that are 2-dimensional perspective drawings. Okay? The scrunched V, the scrunched corner, the not 90 degree, the one that's scrunched in on itself, you're looking down that one. Okay? The corner that is, 90 or more, that's flat. Yeah. And so again, we just take whatever we would get normally. We would have gotten clockwise, and it's the opposite, right? So we would have gotten R if we did these numberings. Well, our H is coming out towards us, so it must be S, right? Okay. Anybody have any questions about that? Yeah? Yeah? Did you guys need any help with these? Everybody's okay on these now? Okay. Let's go ahead and go to the next one. Okay. Did you say yours doesn't have the asterisk, or what's? Okay, so the asterisk is where it has chirality. That's where it's R or S. Okay? So the asterisk is always used for the chiral carbon. And so that is what you're labeling right there, whether that's R or S. Okay? And so, okay, this is actually easier because the H is in the back, right? So when you're labeling an R or S, you always need to put the lowest priority group in the back. It already is that way. So all you have to do now is just figure out what your top priority is, your next highest priority, and so on. This is the highest, next highest, next after that, right? That's going clockwise. You don't have to do anything special, so it's R. Okay? Oh, okay. If you guys want to, I can either finish this up because I have off-stars after this, or we can stop here and then you can take a note and ask me next time, okay? Yeah. Oh, yeah. No, you're fine. Yeah. I have off-stars. So we'll go ahead and finish this up and there'll be a video. Okay. Yeah, anybody that can stay, feel free. I always do my off-stars right after this. Okay, so this one right here. That's fine. That's fine. Yeah, anybody that needs to do the video, feel free. You'll have to skim through all this. Okay. So what we're going to be doing here is we don't have the hydrogen expressed. Okay? But again, we still have V's, don't we? So we have one of the V's already expressed for us, which would be that one. This one, we're very obviously looking down at it, right? That one's coming away from us. And so remember that all tetrahedral shapes are always two V's. There's one V going this way, and that has to be in the plane. There's another V that would be in and out of the plane, like so. Does that make sense? And so the only place left for the hydrogen is coming out towards us, right? And so our hydrogen will be coming out towards us. If you're ever struggling to see this in your head, and I'll be honest, I do forget to say this sort of stuff sometimes, so this is true for all times. I didn't say it. Yeah. For me, this is not difficult to imagine there being hydrogen coming out here. But I can understand some people do have difficulties with that. There's different types of brain setups. And what you can actually do is just draw this out. Yeah, like literally you just draw this out. When you draw it, you'll notice that this is in that plane of the paper, nice V in the plane. And then this one, you'd have to draw it as fading away from you. And then the only spot left would be the wedge coming out towards you, right? Did you want me to take this and draw on it? People, anybody that's listening, let me know if you want me to draw sometime and I can make a video doing it. But yeah, it's not terribly difficult to do once you get the hang of it. And so that means the H is coming towards you, right? And so all we have to do now is the priorities. And so, well, that has to be priority 1, right? And then the next ones are actually kind of a pain in the ass. Yeah, that's why So the next priorities would be this versus this. and those would be a tie because they're CH2s. And then it would be that versus that. That has 3 carbons on it. So that has to be the next highest priority. Okay? And so we have priority 1, priority 2, priority 3, right? Perfect, yep. It'd be counterclockwise, that would normally be S, but the H is coming out the wrong way, so we have to flip that to R. Yeah. And that's that. Yeah, the other one is actually in the correct orientation, isn't it? So the only place to put that H is coming out this way. And it's coming out away from you, which is the way you want it. So all you have to do is just give priorities. And we already know the priorities, actually. This has to be the highest priority right here. This is the next highest priority. And then this one. So counterclockwise, S. Does that make sense? Okay. Did you want to do the next? Well, okay, so if you flip the enantiomer, right? If you give the enantiomer, typically they're going to be opposites. They both have to change the opposite. Okay, and this one again, we have coming out towards us, and then we have going away from us, right? And so the one in the plane of the paper is probably that. These would have to be the ones coming out towards us and away from us, right? Okay, and so the hydrogen is actually coming in out towards us for this one. And so we have to do our labeling. Double bond is going to be the highest. And then this one actually has 3 carbons on, doesn't it? So I was wrong. This one's actually the highest, isn't it? They actually are tied. I'm sorry. I'm wrong. They're tied here. Yeah, they're tied. Because they both have 3 carbons attached. Only 1 hydrogen attached. And so you actually have to go to the next one. That one has 3 again. Yep. And so this is the highest priority. Then this is the next highest priority. And then this one. Exactly. It's R, but the H is towards us, so we have to flip that. And so we end up with S. And then we do the same sort of thing here. So in this case, this one's highest priority. It has the 3 carbons. And then we would go down these, CH2, CH2 tied again, CH2 versus 3 carbons again. And so that one's highest priority. This would get an R, but the hydrogen's coming out towards us, isn't it? So that's an S then. Yeah. Yeah. Any time you do enantiomers, has to flip both of them. Fantastic. If you had any more questions, by the way, this is office hours, so feel free.